Hello everyone, welcome to chapter 16 of Welding Principles and Practices. This chapter is talking about pipe welding and shielded metal arc welding practices. A lot of the codes and standards, many things are going to stretch across to different welding processes as well. Okay, a lot of it's just talking about pipe welding itself, and then of course anytime we change the welding process, there's going to be a few different variations that we'll want to do, a few different tricks and so forth during the welding process. So let's go ahead and get started on this chapter. You have your main objectives. Read through those. History of pipe welding. The first one was used to carry water, made of stone or wood. Very valuable, saves everybody a lot of time from having to bucket pieces over one at a time. You could go long distances, so forth. The first attempt at a welding pipeline was in 1911 with the oxide acetylene. First attempt to arc weld it was in 1922. Major advancements in 1926 when large diameter seamless steel pipe was available. That says seamless steel PIP, but seamless steel pipe. Okay. Covered electrode was introduced in 1930. Huge advancements. So forth. Let's talk about pipe welding today. So you can always follow through on your book. Again, going through this, we're on page 481. Most of the top portions are headlines within your book. If you're seeing this on a PowerPoint, you may want to highlight it in the book as well. Find where it's seen it, find where it's written in your book, highlight it, be able to come back and study and just kind of take a glance back over it. Okay? Pipe welding today, they're made out of many materials and many different sizes. Of course, there's naturally as well more advancements in technology and metallurgy. We can do a lot of things. They can be for many different applications, from underground sewage systems to oil and gas refineries across the nation, even your normal gas into your house and your water lines underneath the city, providing water and sewer lines to your home, as well as steam, boiler systems, hydroelectric, so forth. Piping can be used to carry a medium over a distance and maintain pressure for a lot of different uses within the industrial world today. Most common is a low pressure system, low pressure steam, hot water systems for heating. So this is typically your systems that are up to about 30 or 40 psi. They're just carrying pressure along. They're not a high pressure system to say from 1,500 to 2,000 pounds psi, pounds per square inch of steam, so forth. Naturally, low pressure systems are less critical, less dangerous than high pressure systems. Some of your low pressure systems might include like caustic acids and so forth. You don't want to compress them, but you want to move them across an area. Fertilizer plants. I mean, there's a million different applications we can get into. You know, this book talks a little bit about pipeline stuff, but remember, we use piping systems in so many different things other than just pipelines. All right. So many piping systems are under very high temperatures and pressure. Joint tightness is essential. Power plants, nuclear sites. Welded pipeline forms the underground network, transports natural gas, crude oil, drinking water, and fuel for transportation, for sure. So we've got a branch line here, individual headers coming off of it, possibly tying into something else. Here is a typical, this is actually a photo from ExxonMobil Corporation. Here's your typical pipeline, natural gas pipeline or a crude oil pipeline that you see in an operation going along. So you can see they're setting it to get it together, they'll tack it together. One person, one welder will come along, usually weld the root pass, having a helper with him, he'll clean it up. The second person comes along, does the next pass. Sometimes you'll get in a case like this if it's thin wall piping, to where this is what we call a brother-in-law situation, to where you both start at the top, you'll weld from top to bottom at the same rate and the same speed, or well, hopefully not same speed. One will be a little faster than the other almost always. Or you can pause for a second, let the other welder get going for a second or two, and then you'll start. So that you're not ending at the same time. One will finish, and then you tie in. This helps control distortion. It helps your pipe from opening up on one side. If you were just to weld down one side, the weld contracts and pulls, so your gap would get wider on this side. Speeds up time, makes it a lot faster. You can just keep going down the production line and so forth. Okay? Over 80 million miles of welded and all new lines. 80% are welded. Pipelines underground for many different systems across the nation. So forth. You can read about this. Maritime and Northeast Pipeline transports natural gas. Here, welder works from each side of the pipe. I'm not going to hang up too much on the pipelines and historical sections. It's just kind of impressive to think that these pipelines are out there. They've already been put in. How many miles they're there. At some point you're going to have to go back and start repairing them and so forth. So the cheapest modes of transportation to get some sort of cargo across the nation, instead of having to do it all in each individual truck. So we see a lot of trucks across the road today. Sometimes there's some emission issues as well. So this is a good means of transportation to get it across from place to place. Okay. So let me figure out where we're at in the book here. Product pipeline. We'll move on. The industry is needing pipe fitter, welders, petroleum, natural gas, water, power plants. You know, around here specifically, we got a lot of water. Other places in the country don't have as much water as we do here in the Pacific Northwest. For example, I come from Wyoming. Water's a pretty scarce item. We think it's dry here. They have one river that provides water where I'm at. Very, very limited water ability. So irrigation's not as common. Around here we've got more water, more irrigation. I believe that they're going to try to close in. Some irrigation districts within the state of Oregon have already closed in their canal systems to where they're within a piping system, and therefore there's less evaporation, less waste, less friction. You can get water to where it needs to go without it seeking into the ground and so forth. All right. So as you can see, there's a lot more than just welding on the pipeline that involves. There's tractors, there's equipment operators, there's geological surveying groups, there's engineers, scientists, and so forth that go into putting this pipeline together. It's not just you go out there, dig a hole, and put a pipe in it by any means. There's a lot of jobs created within the industry other than just welding. However, we're in the manufacturing program. That's what we're concerned with for the most part. One thing I want to hit on here is the radiograph technicians check completed welds. They find fault, they cut out and re-welded. Okay? Not always. I mean, usually you'll cut it out, but you may not be the one to do this. So you welded up, and visual inspection is always the first thing you're going to look for. You might have an inspector on the job coming by watching every one as well. You may just be doing a weld, and then an x-ray tech coming along behind you, and he's going to radiograph the weld, inspect it from that point, and go on. Now, something that's really important to know is when we start getting to this level of welding, there's very few mistakes allowed. Okay? This weld is going to go underground carrying some sort of a chemical, or it could be in a power plant or a nuclear plant to where it could be a catastrophic failure, kill somebody, or be very detrimental to the environment as well. Typically, you're allowed 3 mistakes or 3 repairs within 6 months. If you get more than that, you're usually down the road. Now, certain companies are even more strict. 1 repair, nuclear, 1 repair, you're usually down the road. Okay? And we know that we're not going to start out in those industries right away, but over time, we're going to get more comfortable and become a better welder, understand what code quality is, to where we can make that $100 to $150 an hour if we wanted to travel across the world and so forth and chase the money. Okay? A lot of times they'll come back in, they'll flag it, you'll come back, and all bad welds will be flagged with a certain color ribbon. So you could pull on location, and if you had all good welds, it would be fine. If you've seen a bunch of flags, you know there was something wrong. That's usually when you want to start looking at moisture within your electrodes, gas situations, so forth, usually. Okay. After it's welded up and radiographed, then it's ready to be put in the trench or put in a service if it's above ground. So, threaded joints, flanges, bolts and gaskets, lead and hemp joints, it was kind of the thing in the past. Yes, they worked, but you're also getting a huge reduction in material and piping material. So, material I mean by length, and also when you cut threads into something, you're cutting a certain part of the material away from it. When you weld it up, it's still the same thickness of wall thickness, okay? Yes, you are putting so on a threaded pipe system, you are putting a fitting over top of it. However, it can still create a leak even between those 2 systems. It doesn't mean that it's stronger because the fitting is there. What it means is the wall thickness is smaller or thinner, so it can take less pressure, less abuse, less corrosion, so forth. It also takes a lot more time to come back and repair a threaded pipe system a lot of times than if it was welded up correctly the first time it's in place. Saves money on insulation, fittings, so forth. Okay. At the present time, almost all pipe 2 inches in diameter and larger is joined by welding. Some companies have some restrictions on that. Some companies say it's hard to find a lot of welders that are qualified in 2-inch pipe. So they may do 2-inch and below, might still be a threaded fitting, so forth. Advantages of welded piping installations. Permanent installation, it's improved overall strength, low maintenance costs because of leak-proof joints, we just discussed that. The ease of erection. So, you know, a lot of times if we've got if there's a little bit of misalignment within a welded fitting, we can usually find a way to weld it up or to fit the material or the pipe better. So if it's threaded and there's some misalignment, it doesn't go together quite as well. Okay. I like to call it the liquid wrench. Sometimes we're able to fill a little bit bigger of a gap if it's off a 1/2 or 1 degree. Usually you can make it work and get in there and weld it up nice. The improved flow characteristics, a very important part of many different aspects, specifically steam, petrochemical, and acidic materials. It's kind of just like anything else. You know, a good way to explain it is, remember the old school slides when we were kids? You go down, and if you hit a bump where they put the 2 sides together and there's a piece there, you left a piece of skin on that slide, right? Well, the fluid does the same thing. It hits that and it can wear that out, and it builds up gunk on that piece. The liquid and the flow material flowing through the piping system is the exact same way. It's going to build up gunk. You want to make sure that there's less turbulence within the pipe. It's just a nice steady slide, so to say, through the material or through the piping system than catching a piece and being stuck. Reduction in weights due to compactness and lighter weight fittings. If you've ever dealt with the two, you'll know that sometimes by the time you have a threaded fitting, you might end up with 3/8 inch thick of a wall, but if you were having a welded 90-degree fitting, you might be down to the .280, so only a 1/4 inch material. Again, it's almost half less material than what was there or what it was originally spec'd for. Okay? More pleasing appearance, and then a more economical application of insulation. In your book, see if it'll show the slide. Here's what we talk about as far as insulation. Here's this fitting, and we've got to go over this. It's a lot easier to fabricate a piece of sheet metal to go around the insulation. It's got a nice contour as well. Okay, let's break down each one of these. Cost. Welded fittings meet or lower than installed cost of threaded malleable iron fittings of comparable size. Okay? Estimated 50% savings on the cost of material alone. That's without labor and everything else, just the cost of material alone, than threading. The threading cuts the effective thickness of the pipe wall in half, as we specified a few minutes ago. Welding allows us to use pipe with thinner wall to reduce the cost without lowering system efficiency. This also helps contribute to weight factors as well. Strength. Welded fittings have the same thickness as the pipe in which they are used. Okay? Joined to the pipe by equal thickness of weld. Should be if it's going to be a code quality weld. Okay? No loss of strength is caused by the thread cutting, so there's still the same thickness of wall. Less corrosion as well. Life expectancy of the welded system is double than that of the threaded pipe. Joint security. Permanently joined by metal bond. Does not depend upon strength used in wrenching nor the amount of pipe dope applied. So you've got two different types of thread sealant. Usually you'll have tape, a Teflon tape, which most of us have seen this, but some of us haven't. So you'll have a type of Teflon tape that you can put and apply to the threads. It has to be wound in a certain direction so that it tightens with it, instead of the opposite direction where it would untighten or unravel as you're tightening it on. And then on top of that, you would put a liquid Teflon, which kind of helps it lubricate and seal all little air voids as well. Okay? Now, certain codes and certain applications, so I remember doing a boiler system that it required that it have pipe dope or a liquid compound applied to it, which we commonly refer to as pipe dope. And then you would tape it with a thread sealant, and then you would come back and put pipe dope on top of that as well. Okay? There's no chance for leaks due to vibration or stress, which is important because it should not work its way out. It's all one piece of metal at this point. Okay? Flow. The inside diameters of welded fittings and pipe meet exactly. I shouldn't say exactly. There's what we call low-high. So one piece might be low and the other piece might be high. So you're allowed about a 1/8 of an inch overall within the pipe, depending on the code, but that's usually the standard for most of them. So instead of being aligned perfectly this way, you're allowed 1/16 of an inch misalignment all the way around the pipe to a cumulative of 1/8 inch total. So a 16th here and a 16th here, 2/16, 1/8 of an inch. Okay? There are no pockets that create turbulence, clogging, and erosion, eliminated so water or coolant flows freely. By now, we've probably seen some other videos where we talked about how things will create a turbulence and quite possibly sit there and erode and create a micro pressure system around that eddy current, so to say, and that turbulence within the piping system. Installation. No need to calculate overlaps for threading. Makes roughing in quicker because pipe simply cut to length, placed in position, and then welded up. Now this is all relevant to having good welders, okay? And code quality welds. I mean, just like anything, this isn't in a perfect world. However, if a company has a hard time finding good welders and they're consistently failing welds, failing X-ray and not meeting the specifications they need, I've seen companies go back to having like a 2-inch threaded mandatory fitting. They would go spend more time because they didn't nearly have as well qualified welders to be able to install and weld on these systems. Okay? The equipment is lighter and easier to handle. Again, we talked about that. Less weight in the air means less problems, less sag, easier to brace and block systems up. Testing and repair. Threaded piping systems will have leaks to tighten before a system goes into operation. And once you start that, okay, it can be really hard. So say you have 95 threaded fittings in a line, in one line, and your leaks start at fitting number 4, okay, or even number 30. All right. Now they should have been made sure that they're put on, but they usually don't have. Let me back up for a second. They should have been checked and inspected before moving on. Now in welding, that's easy to do. You sometimes maybe what you'll do is you'll prefab pieces like 10 welded pipe joints there. They'll come in, they'll X-ray it, they'll make sure it looks good, it meets inspection, plus they'll do it visually, and they may even pressure check it in the meantime, okay? But as you start threading pieces together, unless you have a bunch of unions to join them, or in between sections, makes it really hard to come back and fix a leak at the beginning if you don't test it until all 90-some fittings are put together, and then you air pressure test it. If you start finding leaks, then it's a lot of work to come back, unthread everything to tighten this one up, and then go back along, okay? Versus if there is a problem with the weld, you can usually go in, cut it out with a torch or a grinder or air arc, fix it right there, you're back in business. You don't have to tear the entire thing apart in order to do so, okay? All right, easy insulation. Went to this slide a few minutes ago. The outside of the pipe and the fitting are identical, so there's, one smooth surface. Okay. This is really important for systems that need to maintain temperatures as well, especially in a place where you see drastic temperature changes, as in Central Oregon or Wyoming, the Rocky Mountain region alone. We have a tremendous amount of temperature variances within a day. From, especially in the fall and the springtime, we might see freezing temperatures at night and then 75 or 80 degrees during the day. Okay? So depending on what it's carrying, the temperature of the surface condition within the material can greatly influence the pressure, the flow, and it can either be a good thing or a bad. So say, for example, we're carrying a liquefied petroleum product, okay? Now say we're in the middle of Central Oregon, it's 20 below zero. The viscosity of that material is going to increase enough to where it's going to be hard to move it, okay? So they may possibly have to run heat tape during certain times of the year. So if it drops below 32 degrees, sensor's going to pick it up, turn the